Okay, this is 8.2 and 8.3 course practice. We're gonna fly through it. 8.2 is 4 questions. It's all about a sine x plus b sine x is equal to r cosine x minus alpha. Okay, where r is the magnitude of a squared plus b squared, and a is equal to inverse tan b over a. Okay, sorry, alpha. Let me carry this over and put it into our beautiful formula sheet over here. Next, okay, and we're gonna put it down. Where do I put this? Here on the right. Okay, go here. Okay, a cosine x plus b sine x is equal to r cosine x minus alpha. Okay, where r is root a squared plus b squared, and alpha is equal to tan inverse b over a. Okay, always tan inverse. Let's say they didn't give you this in the order like this. Tan inverse, remember, when you find an angle, it's always y over x. What does that mean? What I mean is y corresponds to sine, so you always take the coefficient of sine up, okay, and the one down is the coefficient of cosine. Type. Let's do this. What's the value of r if 4 cosine x plus 2 root 21 sine x is equal to this? R, we said, is the magnitude, right? So square root of 4 squared plus 2 root 21 كله square 10. Extremely easy. No need to waste time on this. Okay. Find the roots of the equation 3 cosine theta minus root 3 sine theta equals root 3. Okay. Where the domain is in between minus 180 and 180. Okay. So obviously they're doing it step by step, and you're just solving the steps. Okay. How I can do this? Obviously, you can't solve any equation with cosine and sine together, okay? So you have to rewrite it. And we know when you have cosine and sine together, you can rewrite it as r cosine theta minus alpha. So that's what they did in the first step, okay? So they're saying if r is equal to 2 root k, then what is k? So they're telling you find r and find alpha. We don't even need the steps. We don't need the formula. We don't need this. We can do it on our own. R would be the square root of a squared plus b squared, right? So let's fix it. B is root 3, negative root 3 يعني. Okay, but it doesn't matter as long as you put it under the brackets and the square outside, huh? Okay, and then 3 is here. You get 2 root 3, so k is obviously 3. Then to find alpha, we do shift tan. I'm on degrees. Yeah, we do shift tan, coefficient of sine over coefficient of cosine. So root 3, sorry. Negative root 3 على 3. You get negative 30. So alpha is negative 30 degrees. So it's going to be, how it's going to look? It's r cosine theta minus alpha. It's going to be, we said r is 2 root 3. Okay. Cosine theta minus alpha. Alpha is minus 30. فبتصير هيك and it becomes plus. Okay. شايفين? Okay. So the given equation can be written in the form 2 root, we change this all into 2 root 3 cosine theta plus 30 is equal to what? Root 3. صح? So fully when you do it, it's gonna look like this. You can cancel root 3. Okay, you're gonna get 2 cosine theta plus 30 is equal to now 1, right? After I divide by root 3. Now if you divide by 2, you're gonna get cosine theta plus 30 is equal to half, right? And half is just 0.5. Okay, so this is the second one. If we use the first and second, and then obviously here they're just gonna ask you to solve. Type. If you do shift cosine half, you should get 60, I think. You get 60. So you get first solution is 60. Always for cosine, what do? We do 360 minus, okay? Yeah, for cosine you do 3. You know what? No, not 360 minus. No, forget about that. Yeah, you know what? Actually, do it. Sorry. Remember, for sine you do 180 minus. For tan you do 180 plus. For cosine you do 360 minus. Okay? But before I do 360 minus, let's use the same rules I taught you in the previous recordings. For cosine, any solution you get, also the negative of that solution is also correct. Why? I wrote it for you here. The unit circle, I told you cosine theta, anytime you get solution, it's equal to cosine of the negative theta. So anytime you get 30 مثلا, negative 30 is also a solution. Okay? But some people make this mistake. What do? They do this. They take 30 other side, they get theta is equal to 30, and then the other theta is just the negative of this, which is negative 30. No, mamnu. Okay? Anytime you have theta plus 30, maybe 2 theta, maybe 5 theta, or theta plus 50, you're not allowed. You solve it كأنه, if you want to make your life a bit easier, you can just call this all u. Okay? Just so you can understand what I'm doing. You can call this u. Okay? Look. Just so you can understand. Cosine u, u, u. Okay? So imagine u is the angle. So we said cosine, the solution to it is 60, right? The solution is 60. What's the other solution always? The negative of it, right? Okay? Then we know that u is equal to, we said u is theta plus 30, huh? So you can just change this back now. Theta plus 30 is equal to 60. Theta plus 30 is equal to negative 60. If you do 360 minus 60, you get 300. Okay? Which, if you do theta plus 30 is equal to 300, you're going to get theta is equal to 270 degrees. But the problem is it doesn't fit in the domain. Okay? So this is wrong. If you get these two solutions, take 30 other side, you're going to get theta is equal to 30 degrees. And here take 30 other side, you're going to get theta is equal to negative 90 degrees. Do these both fit in the domain? Of course they do. Okay? This u substitution, don't do it. But I'm just doing it to let you know, to visualize it for you, to make you understand, to get it printed in your head that you solve when you're changing solutions. You don't solve this until you get all your solution set. I had a question like this in the other recording, 8.1, when we got 2 theta is equal to 60. Okay? As one of the sign solutions. Okay, I told you don't divide by 2 and then find the other solution. No. You continue solving. You get 2 theta equals 180 minus 60. This was for a sign question, I think. Okay? You have to find all your solution set and then you finally solve for theta. Okay? Please, don't make this silly mistake. It's very, very stupid mistake to make. Okay? Type. Question 3. If minus 6 cosine theta plus 2 root 3 sine theta is equal to root k cosine theta minus alpha. Okay, so obviously root k in this case is our r. Our r is our r. Okay, how to find r? It's always square root a squared plus b squared. So square root minus 6 square plus b squared, which is 2 root 3 squared, right? Okay, you get 4 root 3. But what do they do it? How do they do it? They didn't say something root k. No. They want it as one radical. And you know 4 root 3, if you get this on your calculator, how do you make this under one radical? You need to put this 4 back inside, right? So if you want to put it back inside, you don't do 4 times 3, please no. When you put it back inside, you do 4 squared times 3, right? Because when you take it outside of the radical, you cancel the square out. Okay, and then 4 squared times 3 is just 48. So k in this case is 48, and obviously they want us to find alpha. We do shift tan b over a, so 2 root 3 over minus 6. 2 root 3 over negative 6, you get negative 30. But what's the problem? It doesn't fit in the domain, right? So if you put negative 30, it's wrong. طب نحن we're doing tan, right? We got that alpha is equal to tan inverse equals negative 30, right? When you're doing tan, what's the second solution? Always 180 plus your first solution, right? So you get 150 degrees. Okay, these are very important. You know what? I'm going to write them for you. Actually, I wrote them here. Okay, these 3, memorize them with your heart. Okay, once you know this, all you have to do is just this, plus 360k. Okay, if it fits in the domain. Okay, all you have to do is that. Okay, but for tan, it's 180k, huh? Please don't make this mistake. The maximum value of the expression is what? Okay. When you write this, you get this, right? You get root 48 cosine theta minus 150, right? This is your expression. Isn't this just a cosine function that looks like this? Right? With maximum value, how much is the maximum value? Root 48. طب الذكي هيجي يقول لي why is it 48 يا وليد؟ ما حبيبي because they put what they put now? Square. Okay? They put square. What does the square do? It cancels that. So what's the graph gonna look like now? Heck, right? 48 as the maximum value. طيب, these questions always come. I'm surprised this is the first one I saw. When you rewrite it and you get your nice equation that looks like this, r cosine theta minus alpha, you need to know that r is كمان the maximum value, okay, of a cosine x plus b sine x. The maximum value of this would be r. Okay, you need to know this. Okay, مش انت you wrote it like this, isn't this the same as this? Okay, طب what's the maximum value of this? Wouldn't the maximum value of this be the same as the maximum value of this since they're the same equation? Yes. Okay, so you're gonna see questions like this. They're gonna ask you what's the maximum value, and sometimes they say what's the minimum value. Minimum value would just be the negative r, right? Very easy. Question 4. Consider the equation 3 cosine theta plus 12 sine theta. Equations equivalent to root a cosine theta minus b. Very easy. And it's the same questions repeated over and over again. Let's to find a, it's the r. You take the magnitude. So 3 squared plus 12 squared. And you get 3 root 17. But they want it as one radical. So what do? You have to take the 3 back inside. And when you take the 3 back inside, you do 3 squared times 17, صح? So 3 squared times 17. 153, صح? What's the value of tan b? Here they didn't ask you for the angle. They're saying tan b. طب نحن we know alpha, the angle alpha is equal to tan inverse b over a. B over a in this case is 12 over 3, right? طب I don't want the value of alpha. I want what is tan of the alpha. So I just take the tan to the other side. I'm gonna get tan alpha is 12 over 3. Okay? Which is 4, huh? 4. Please note that the formula here actually, it's not given like this. The way they give it actually in the book is like this. They do this, huh? So I just make your life a bit easier. Tan alpha is equal to b over a. Okay, and then you can just do shift tan. So you can rewrite it in any way you want, okay? We're done 8.2. Oh, I had to close my calculator. We're done 8.2. Let me open now 8.3. Okay, so 8.3 is all about derivation and differentiation for trigonometric functions. I think you screenshotted this before, but I want to make it in a way where it's all one page. I'm gonna kind of scale it. Can I? No, I won't go out of it. Okay, this is. Oh no. Okay, this is good. Type. I'll now put the rules of differentiation over here. Okay, recording, right? Okay, I'll write them down and then show you. Okay, let me. Okay, so this is our nice formula sheet. I updated it now to include our derivation and integration. Okay, derivative of sine is cosine. Okay, if it's just sine x, then it's just gonna be simply cosine x. But sometimes there's stuff under the sine, like 5x, so you have to multiply by the derivative of it. Okay, so derivative of sine u is cosine u times u prime. Okay, derivative of cosine u is negative sine u times u prime. Integral sine ax is just going back. Okay, how do you get to sine? Okay, when you derive what, do you get sine? When you derive cosine, you get negative sine. But okay, let's move this negative to the other side. That means if you derive negative cosine, you get sine. So that means when you integrate sine, you can get negative cosine. Okay, sometimes you have something under the sine, like ax, so you just have to divide by a. Okay, obviously plus c, huh? Yeah, and then for integral cosine, it's just sine. Okay, because when you derive what, do you get cosine? Integral is just the other way around, huh? Of derivative. So if you derive sine, you get cosine. That means if you integrate cosine, you get sine. You understand what I mean? طيب, please don't forget the plus c. Moving on over here. Let's start. Okay, let k be a non-zero constant. Derivative of sine kx. Derivative of sine kx is 1 over k cosine kx. No, this is wrong. When you see 1 over, that's for what? Integral. See the over a? You know what? Let me write it in a better way. Okay, because the book doesn't do over a. They do 1 over a times. Which is the same thing, يعني هبل. But let's do it the way the book shows you. Because at the end of the day, that's how the questions will come. Okay, let's move to the side here. Okay, 1 over a. No, I'm shaking. 0.9. 1 over a times 1 over a times. Okay, so it's only for integral do you see the 1 over a. Type. So this is wrong. Okay, definitely wrong. Derivative of sine is cosine, but you multiply. Remember, for deriving, you multiply by kx prime, which is just k. Okay, so you're supposed to multiply, not divide by. Okay, derivative of cosine is cosine, obviously not. Integral sine is 1 over k cosine kx plus c. What are they missing here? They're missing the negative, right? It should be negative. Integral sine is negative cosine. Okay, so this is wrong. Integral cosine is, no, this is correct for the most part, but actually there's no negative, well, it should be 1 over k. Okay, so this is wrong. So none of the above. Question 2. Anna, is my voice yeah, okay. Okay, inverse functions. I'm gonna go over them really quickly because yani they're calm. Okay, you need to know about sine inverse of x. Okay, cosine inverse of x and then tan inverse of x. There's a few rules. I'm gonna go over them one by one. They're just things you need to know so that you can answer the questions. Okay, I'm not gonna draw the graphs for you because they're very not for your level. There's no need any. You know, actually, I'm gonna draw it just so you can kind of get the hang of it. Okay, I'm gonna draw first the sine function. Okay, and I'm gonna explain to you how it goes. Okay, so sine kind of looks like this. We're gonna go from minus pi over 2 to pi over 2 over here. Okay, I'm gonna draw it. It's gonna go down. What? Pi over, yeah, it goes like this, right? Wait, what? No, yeah, I don't know why I'm bugging. It doesn't go like this. It goes هون minimum هون. Okay, wait, right? Then it can continue later and go like this, but we don't want that. Okay, I know why I'm doing this is because this gives me the full range of sine. Okay, you can continue it, but why do we only study this part of the graph of sine x? Why do we only study from x belongs to minus pi over 2, pi over 2? Why am I only studying this part of the graph? Okay, in math, we're very lazy. Okay, and to be a good mathematician, you need to be lazy. Okay, why do you want to bother studying all of this? Why do you want to go over here? طب خلاص, you're studying these values. This gave you all of the possible values for sine from 1, right, to negative 1. So for that reason, we choose to ignore everything else. Okay, we stay in this domain over here. Type. So what do we know about sine x? The domain of it is from minus pi over 2 to pi over 2. So this is the domain, right? Domain of definition. Okay, no, but it can go, but we're studying this part. And we know that the range, right, is from minus 1 to 1, right? Look at the y values from minus 1 to 1. طيب أنا when I come and tell you sine inverse, what does the inverse do? What is this inverse? Okay, it basically means opposite. For this over here goes to the range, and this over here goes to the domain. Okay, so how does sine inverse look? You need to know this. Its domain is from minus 1 to 1. Its range is minus pi over 2, pi over 2. So it's gonna look like this. Okay, let me show you. Minus 1 over here, 1 over here. Okay, and it goes, I think, I don't remember the shape. Let me see. Arc sine x. Yeah, like this. It looks the same almost. When this is going like that, it goes like this. There's some properties to it. Hake. Okay, and it goes like this. Okay, that's the blue graph is arc sine. Oh, why am I doing it there? It should be hake. Okay, so شو اتفقنا؟ اتفقنا انه الدومين تبعتها minus 1 1 and the range is minus pi over 2, pi over 2. Okay, so this is arc sine. What do you need to know? This. Okay, because sometimes you're gonna get a question where it's not in the domain, so you're not allowed to solve. That's pretty much it. Okay, طيب, how about cosine inverse? let's take a look at cosine x really quickly. Okay, cosine x looks like this, right? Let's see. Cosine x has, it comes up, it starts like this, right? It starts up. Oh no, I'm shake. Pen. Hick. Right? Don't have much mouse space because there's stuff on my desk. If it goes هيك وبترجع بتطلع هيك. Okay, so to study one full revolution of cosine x, right, it reaches this minimum value at pi. Okay, so and I want the easiest one. Do I go from, this is pi over 2 here, صح? And this is minus pi over 2. If I consider like the previous example for sine, if I consider minus pi over 2, pi over 2, am I going to be examining and identifying the full range? No. So here I'm only going from 0 till 1. But I want the full range. We could actually start from 0 till pi, right? This is my full range over here. This gives me a full range. For cosine x, we say our domain, we're going to study from 0 till pi. And the range we're going to study from is, as usual, minus 1 to 1. Now what's interesting here? When you come and do cosine inverse هلا, you swap them. The domain now becomes minus 1, 1 as usual, but the range is what? 0 to pi. Okay? How does it look? It looks like this. Okay? We're gonna draw it. As usual, 1, 2, 3, minus 1, 1, 2, 3, 1. Okay? Yeah, for arc cosine, I had to Google it, man. I forgot these inverse functions, how they look. Because you're not required to know the graph. It looks like this. Okay, kind of like the one up here. But this one is decreasing. Okay, let's move it down a bit. Yeah, هيك. Okay, فاتفقنا الرينج from where to where? From... Wait, huh? Yeah, I'm saying I'm bugging. It doesn't go down. Because we said the range, yeah. Yeah, no, it doesn't go down. Let me take this fully down. Take this one down as well. Heck. Okay, because I told you the range is from 0 to pi, so it's not allowed to go down to the negatives. Okay, just so you can understand. This is stuff you don't need to know, but so you can kind of understand it. Okay, this is how inverse cosine looks. Okay, so this is inverse cosine. Let's go now to inverse tan. I'm not going to spend too much time on it, but inverse tan is kind of the interesting one because where am I now? Trying to look at the copybook. Yeah, inverse tan. نحن اتفقنا, we know tan looks like this, right? Asymptote over here at pi over 2, let's do it in red. Pi over 2 and 1 2 3 minus pi over 2 في asymptotes, right? فبتنزل okay, and it looks like this. هيك تطلع بالنص وبترجع بتطلع هيك. Okay, هالتان. طيب, so obviously what's our domain? It's kind of obvious. Our domain here is minus pi over 2, pi over 2, right? But open brackets. Okay, if you get this in an exam, now teachers are not required to deduct marks on it, but if you write this in any exam, it's going to be wrong. Why? Because in math, you were taught this in grade 8. When you use square brackets, it means this is included. But when you use open brackets like this, parentheses, it means these two aren't included. Okay? Are they included? Of course not. They're asymptotes. You can't write it. Okay? والrange تبعتها, range we go from minus infinity to plus infinity. Why? Because look, we're starting here, we're ending up there. Don't know why I didn't write any of this in my copybook. I'm trying to look for it, but I can't find it. Anyways, فهلا when you get tan inverse, it's the same thing, but it's just the other way around. Let me do a line هيك, one more هيك. Tan inverse, it's gonna, this one I'm not gonna Google because I actually remember it. Okay, what's gonna happen now for tan inverse? Tan inverse, اتفقنا, we swap the range and the domain, right? The domain now is minus infinity positive infinity. Okay, range تبعتها minus pi over 2 pi over 2. Please open brackets, huh? Because they're not included. If you get it, but you're never gonna get anything, I guess. Anyways, at minus pi over 2 and over here pi over 2, okay, there's asymptotes, okay, because they're not included. Okay, it looks like this. So your graph's actually gonna look like this. Starts all the way at negative infinity, comes up here, and continues to positive infinity. This is actually how tan inverse looks. Okay, I remember seeing this. Anyways, do you need to know how these graphs look? No. So why did I draw them for you? Just so you can help understand. You need to know the domain of them and the range of them. Okay, very important, please. Okay, let's start. Sine inverse inverse x is equal to negative x. So when can you cancel? Sine and sine inverse always cancel, but the rule has to be that your x fits the domain. Okay, it needs to fit the domain. What's the domain of sine inverse x? Sine inverse and cosine inverse, we said the domain is in between minus 1 and 1, so this is correct. Sine inverse of x is equal to x for minus pi over 2 pi over 2. This is correct. You're going to tell me, didn't we say it's between minus 1 and 1? Please pay attention to what's inside. Okay, what's inside? What's the x falling under? Okay, here the x is falling under sine inverse. Okay, the domain of sine inverse is between minus 1 and 1. Here, x is falling under sine. And what's the domain of sine? It's between minus pi over 2 and pi over 2. Okay, sine, not sine inverse here. Okay, but pay attention. Cosine inverse of x. X is falling under cosine inverse. Is the domain of cosine inverse anything greater than 0? No, obviously not. It's correct. Here, x is falling under cosine. What's the domain of cosine? Cosine is in between. Okay, guys, I just understood this one. I don't know why I bugged on it. Cosine minus x, we said the domain of cosine is 0 pi. But what's the problem here? All my problems come from this. Okay, here's my advice to you. Okay, whenever you see a question like this, these questions are extremely straightforward. They're very, very easy. You just need to know the domains of sine, cosine, and tan. Okay, and their inverse functions. By the way, if you know the domains of sine, cosine, and tan, that's all you need. You can just swap them with the range if you're working for the inverse. Anyways, this negative is the problem. Whenever you see the negative, you need to get rid of it. Okay, cosine of minus x, we know cosine of minus x is equal to cosine x. Okay, and we can just take it out as positive x. So what's wrong here is هني حطولك minus x. This is wrong. Okay, because this becomes positive. Okay, and you're gonna get x. This is fine. Okay, so why am I saying all this? When you see cosine of negative something, it comes out positive. If they took it out as negative, and you can see it as negative, if they took it out as negative, that means that negative x should be within the domain 0 and pi, right? But what did they put here? They put positive x in between the domain 0 pi. Okay, if you wanted to make this x positive, you'd have to divide by negative on both sides. Okay, so it's gonna look like this, in between negative pi, you see? So basically, you can't win on both sides. If you want to take it out as negative, you'd have to put negative here. If you don't want to put negative here, at least divide by negative to make it negative pi over here. Okay, but they didn't do any of that. So now someone's gonna come and tell me, what was the first one correct? Sine inverse of negative x, it comes out as negative x. Okay, so we're gonna tell me, okay, well, it came out as negative x. Why in the domain they kept it as positive and it's correct? Now look, okay, put negative x in between a negative 1 and 1. Remember the domain of sine inverse is negative 1 and 1, right? طب okay, divide هلا by negative 1. You're gonna get this. Remember the sign, it flips, right? When you divide by negative, it flips, so it becomes like this, right? And this becomes 1, this becomes negative 1. Isn't this the same exact thing as this? You see? So they actually already did it. But when you divide by negative 1, 1 over negative 1 is negative 1. Negative 1 over negative 1 is 1. But it doesn't really make a difference here. So when you're working with pi, you should see a difference. Anyway, I'm gonna give you a small generalization. Okay? Work as if you're working with u. Sometimes they might put you 5x. Let's say they put for you 5x here. Okay? I'm just giving a sample question. Let's say you saw this in the exam. Okay? What do? Work as if it's called u. Okay? And put u in the domain. What's the domain of sine inverse? Minus 1 and 1. But and I know u is equal to 5x, right? So if I want to write it in terms of x, I just have to divide by 5. So divide by 5, change this to x. Okay, so if you wanted to solve this as 5x, if they put for you 5x in the brackets, work as if it's u and then change it back. So you're gonna get this. So I'm re-explaining it a lot because I feel like, it's a bit complicated for you. Yeah, خلاص, that's it. Over here it's positive, they kept it fine. Over here it's positive, but it's wrong because the domain is wrong. It should be in between minus 1, 1. Here it's wrong. Why? Because when they took it out as minus x, they didn't put it in the domain. So when you see negative, okay, you should put it in the domain as negative. So it should look like this, right? And then when you divide by negative 1, it's gonna look like this, right? Remember the signs flip, huh? So it should look like this, okay? Anyways, let me continue. So this is why this is wrong. They didn't put negative x in the domain. Tan inverse x is for all x greater than 0. Top y. Okay, let's see. Tan inverse of x, what's the domain of it? Negative infinity, positive infinity. Right? Top, any x greater than 0. That's correct. Why is that wrong? We're saying literally any number in between minus infinity and positive infinity. Tan inverse tan x for all x. What's the domain of tan x? Tan, it's minus pi over 2, pi over 2. Pi over 2. So is it for all x? Obviously not. Okay, it's a bit of an annoying question. And did I skip question 1? No, I did it. Okay, let's continue. And I don't like the sine inverse, cosine inverse stuff. Okay, if y equals cosine 4x, what is the derivative of cosine 4x? Derivative of cosine is negative sine, right? And remember, I told you if there's something inside, you multiply by u prime. What's the derivative of 4x? 4. Okay, so I told you. You take it out normally. What's the derivative of cosine? Negative sine. What do you put inside the brackets? Always what's originally inside the brackets. And you multiply by the derivative of what's inside. Okay, so it's kind of like chain rule. Okay, so you're going to get negative 4 sine 4x. Derivative of inside times derivative of outside. What's the derivative of outside? Negative sine, right? What's the derivative of inside? 4. So you add that 4 at the outside. Okay, how about sine 2x? What's the derivative of sine? Cosine. Okay, sine 2x, you put cosine 2x. What's the derivative of 2x? 2. So you're going to get 2 cosine 2x. Very, very nice and calm and chill and petite and easy to solve. Question 4. If y equals cosine cube x, then y prime at x equals pi over 6 is k over 8. What is the value of k? Type, okay. You need to derive cosine cube x, okay? If anything, and I'm going to give you my advice, okay? I just got... apparently this is a very stupid question. I looked at this, I didn't know what to do, صراحة. Obviously it's not going to be like this, okay? It's not this easy, right? We're not going to take the power down. I asked my mom and I got yelled at because apparently this is a very stupid question. If you see, okay, we know that the derivative of cosine x is negative sine x, right? The derivative takes you here, right? If you have something, this is the general rule. If you have something that isn't like x, okay, call it u. Okay, this is basically chain rule. Okay, this is like more than one thing under the bracket. You derivative of the outside times derivative of the inside. Okay, what's the derivative of the outside? It becomes 3 cosine squared x. But you need to multiply by the derivative of the inside, which is cosine. Okay, kind of look at it like this, huh? Look, it's like this, cosine x cube. Okay, think of it like this. Do chain rule on it, right? Do chain rule on it. 3 cosine squared x times derivative of the inside, which is what? Negative sine x. Okay, so you're going to get negative 3 cosine squared x sine x. Okay, this is how to do it. Okay, I honestly didn't see this. I don't know why. Anyways, I don't know, the way my mom teaches me it, she tells me, call this, anytime you see something with a power, just call it u. Okay, and do it like this. It's 3u squared times u prime. Okay, this is actually where this comes from, by the way, over here. Okay. Anyways, they're saying plug in pi over 6. So go to your calculator and plug in radians pi over 6. So negative 3 cosine, let's see, cosine squared. So cosine pi over 6 squared times sine pi over 6. Okay, you get minus 9 over 8. So k is negative 9. Very easy. Okay, if y is equal to x sine x, then y... Okay, see, this is interesting. Then y prime at x equals pi over 6 is something. Let's take a look here. X sine x. What's this? You want to derive this. Is it one full thing? It's actually what? Two different equations. You're multiplying x times sine x. So what rule do you use when you're multiplying two things and you want to derive? You use product rule. So you use u prime v plus v prime u. So x sine x becomes, let's apply it. What's the derivative of x? 1 times v, which is sine x, plus v prime. What's the derivative of sine x? Cosine x. U is x. Okay, so you're going to get sine x plus x cosine x. Plug in pi over 6. So sine pi over 6 plus pi over 6 times cosine pi over 6. Let's press equal. Oh, that's a problem. Okay, when you get the case of this, you need to do lovely step by step. You need to do it by hand. Okay, actually don't panic. If you do sine pi over 6, we can do it step by step. Okay, so we can do this. So it's gonna be 1 over 2 plus pi over 6 times cosine pi over 6. What's cosine pi over 6? Let's do it. I think it's root 3 over 2 or something like this. It should be root 3 over 2. Yeah, root 3 over 2. So don't panic. It's calm. Okay, how do you multiply this? Root 3 times pi is pi root 3. And 6 times 2 is 12. Plus 1 over 2. Type, how do you add this? You need to do same denominator, right? Really, if you don't know how to add fractions in grade 11S, please عيب والله عيب عليك. I say no haram, and maybe it doesn't know, but come on, you're taking this SAT this year, or you took IG math, whatever external you need to do, and you don't know how to add fractions, عيب والله. Okay, multiply by 6 up and down, you get 6 over 12. So you're gonna get this. You're gonna get pi root 3 plus 6 over 12. Okay, so root 3 pi plus 6 over m, which is 12. Very easy. I need to speed run because I need to go. Question 5. Integral 8 sine 4x. Okay, anytime you see a number here, take it outside. Okay, always. It's a constant, take it outside. Okay, so you're gonna get 8 integral sine 4x. Right, what's the rule? Integral of sine ax, أول شيء, it's 1 over a, so 1 over 4, times sine, we change it to negative cosine 4x. هيدا cancel, 2 times minus cosine 4x, right? Okay, plus c. If it's written, don't forget that. Yeah, sorry, 2 minus cosine, so you obviously can't write it as minus cosine, so you take the negative outside, becomes negative 2 cosine 4x plus c. Type 18 cosine 3x. Take 18 outside. Integral cosine 3x dx, right? Type, let's see. What's the rule? 1 over a, right? So 18 times 1 over a, so 1 over 3. What's integral cosine? It's sine 3x and plus c. 6 sine 3x plus c. The rules are here in case you don't know. Okay, these two at the bottom. Okay. Question 6. If x is equal to tan inverse minus 3, then cosine x is equal to k over root 10, and sine x is equal to m over root 10. Yeah, okay, I don't know why I bugged here. If x is equal to tan inverse 3, that means tan x is equal to negative 3, right? Just take tan to the other side. But if I have tan x is equal to negative 3, can I find cosine and sine? Of course I can. It's not hard. Before doing this, you need to check if it fits the domain. We know tan inverse, the domain of it is minus infinity, positive infinity, but this is completely fine, okay? Tan x is equal to negative 3. Okay, you can solve this very easily. Okay, we can do 1 plus tan squared is equal to secant squared to find cosine, right? Okay, so 1 plus 9, because negative 3 squared is 9, is equal to 1 over cosine squared. So it's gonna be 1 over cosine squared is gonna be equal to root 10. طيب. What I don't know here is what quadrant are you working in? Okay, yeah. ف 1 over cosine squared. What? Yeah, if 1 over. What am I doing? Yeah, 1 over cosine squared will be equal to 10, right? So take the square root of both sides. You're gonna get 1 over cosine is equal to root 10. So obviously, just put them both, like, take the reciprocal. You're gonna get, swap these two. You can get 1 over root 10 is equal to cosine. Okay, so k in this case is 1. Thing is, I don't know if tan is negative. يعني, you can either be working in this quadrant where cosine is negative, where cosine is positive but sine is negative, or you can be working in this quadrant where sine is positive and cosine is negative. I don't know. Let me check. Wait. Okay, I just figured this out. When we say tan inverse, what's the domain of tan inverse? It's minus infinity, positive infinity. But what's the range of it? What's the range? The range is minus pi over 2, pi over 2. And what's this? By the way, minus pi over 2 is over here, right? Negative 90. And positive is over here. So in between these two. So you can only be like this. Okay? Like this. Okay? So we can only work in quadrant 2 or 3. Okay? Sorry, Anna, what am I doing? Of course, what? Shit. Okay, the range is correct, but I don't know why. Minus pi over 2 is here, pi over 2 is here. So you take everything on the right side, not on the left side. You're gonna tell me, Walid, how do I know? Okay, go from negative 90 to 90. So you can pass by 0, 45, negative 45. So you're passing like this. You see? Heck. Right? For here, okay, for which one of these two quadrants has tan negative? Here, cosine positive, sine positive. So akid tan will be positive. Here, cosine positive, but sine is negative, obviously, right? So we're working in quadrant 4, IV. Okay? Or is it VI? I don't know. That doesn't matter. Quadrant 4. Okay. So we're here. So we're going to take cosine as positive. We're going to take the positive root. So we're going to say cosine is 1 over root 10, positive. Okay. And then when I find sine, I'm going to take the negative value. Okay. This is very important. This step is very important. Okay. So we know tan x is negative 3. We have cosine. To find sine, I'm just going to use cosine squared plus sine squared. It's way easier. Okay. So remember, cosine squared plus sine squared is equal to 1. So sine is just going to be equal to root 1 minus cosine squared. But we're going to take the negative root. Okay. So square root 1 minus cosine squared. And cosine we found is 1 over root 10. Okay, outside square, take the negative value. So they rationalized it for you. Okay. Okay. If you see this, okay, if you see this on the calculator, but in the exam they want the radical to be down, okay, to take the radical down, okay, what? Yeah, to take the radical down, you can take it down, but you have to remove the denominator. Okay, that's how it works. You must not say the calculator gave you 2 root 5 over 5. Okay, to write it in terms of k over radical, I don't know, whatever, 5. Okay, to do this, you can take the radical 5 down, but on the condition you remove this. So it will be 2 over radical 5. Okay. If you see this, if you see something like this on your calculator, you can take the radical down, but just get rid of the 10. Okay, just take it as a rule. To explain why, I don't have time to explain why. Okay, but we said take the negative root, right? So we're going to write it like this. Okay, so what over root 10? Negative 3 over root 10. Okay, very easy. Question 7, I think there's 12 questions. So yeah, let me go a bit faster. Okay, if x equals to cosine inverse of this, then sine x is equal to something, sine, whatever. Cosine inverse. What is the domain of it? The domain of it is 0 pi, right? And this fits in the domain عادي. What does it? sorry, الدومين تبعتها minus 1 1, right? الrange remember cosine inverse the domain is minus 1. Range is from 0 pi. Okay, so what are we going to be considering from 0 0 pi is here 180. So we're going to be considering quadrants 1 and 2. Okay, let's see. They told us cosine x is equal to cosine inverse this. So that means cosine x is equal to negative root 14 over root 15. When is cosine negative in these two quadrants? Which one? Obviously here, right? So we're going to be working in quadrant 2. So that means cosine is negative, sine is positive, and tan should be negative as well. Okay, can we find sine? Yes, we said sine is equal to square root 1 minus cosine squared. I'm gonna go a bit faster. Are we gonna take positive or negative root? Positive root. Why? Because we're in quadrant 2. Why are we in quadrant 2? Because the range of cosine is between 0 and pi, so between these two. And since they told us cosine is negative, that means we're gonna be considering quadrant 2. Type, yalla, square root 1 minus cosine squared. So cosine is just root 14. You can put the negative if you want, no need. Over root 15. So you're gonna get root 15 over 15. But like I told you, when they want the radical denominator, just take it down and cancel out the denominator. So you're gonna get what? 1 over root 15. Easy. Tan 1 plus tan squared is equal to secant squared, right? So tan is equal to secant squared minus 1 under the radical, right? And since we said tan is negative, you have to take the negative root, okay? So it's going to be negative square root secant squared. So 1 over whatever this is, root 14 over root 15 squared, right? Secant squared minus 1. Very easy. You're gonna get negative root 14 over 14. Like I said, they want it in the denominator. So what do? Take it down and cancel the denominator. So you're gonna get negative 1 over root 14. So m is what? Negative 1. Very easy. Question 8. خلاص ما عادش بدي cosine inverse. Okay, these are easy. W of x, okay, they want you to integrate 100 cosine for x. I tell you always, the number here, take it outside. Okay, then what do? 1 over a. What's a? 4. So times 1 over 4. What's the integral of cosine? It's negative. So is it? No, it's just sine. Integral cosine is just sine. Sine 4x plus c. Right? Just use the formula. Okay, so cancel 25 sine 4x plus c. Very easy. Formula. Question 9. If y equals 10x sine 3x plus cosine 3x, then y prime is equal to what? Here you have two equations, right? So you have to use product rule. So use u prime v plus v prime u. Type u prime. What's the derivative of 10x? 10. V is just sine 3x plus cosine 3x plus v prime u. What's the derivative of sine 3x? Sine 3x, its derivative is cosine 3x times 3, right? Yeah? Remember, it's times u prime, right? So sine, derivative is cosine, times what's inside? 3x. You have to derive it, okay? Derivative inside times derivative outside, right? Okay? But don't forget, you also have this. V is this whole thing, okay? So plus v prime is this plus the derivative of cosine 3x. What's the derivative of cosine? Negative sine 3x, okay? Times u prime, come in. What's u prime here? 3, okay? So this is v prime. This is all v prime. This is the derivative of this here, okay? Times u, which is 10x. Okay, let's clean all of this up. Okay, you're gonna get 10 sine 3x plus cosine 3x, okay, over here, plus 3 cosine 3x minus 3 sine 3x with the 10x outside. Okay, how do you want to do this? I think we can factor out the 3 and take it outside, right? So you're going to get 10 sine 3x plus cosine 3x, okay, plus 30x cosine 3x minus 3 sine 3x. Let's see, what else can you do? Whoa, wait. This is my fault. This is minus 3, I took it out. I don't know why I kept it in. Okay, what they did here, I'm trying to see and understand what's going on. They collected the coefficients of sine and cosine and they put them together, okay? So what's the coefficient of sine here? The coefficient of sine here is 10, okay? And the coefficient of sine here is negative 30x, right? You could say it's, if you take it's negative 30x, right? So they did this. They collected them and put them for sine 3x, okay? And then they collected the coefficients of cosine 3x. Here the coefficients of cosine is 10, right? So 10. And here the coefficient of cosine is just 30x. And they did it like this. Cosine 3x. Let's take a look. That's how they did. So 10 plus negative 30x. So they put the plus, and that's just annoying. Okay, plus 10 plus 30x cosine 3x. So you just collected it, and it's just simplification. It's bullshit. Question 10. If y is equals to 11 sine 3x plus 7 cosine 3x, then what's y prime? You derive it one by one, not product rule, because you're not multiplying. Okay, 11 sine 3x. Always take the constant, the coefficient, always take it to the side. Times, what's the derivative of sine? Cosine 3x times always derivative of inside 3. Okay, plus 7, take it always to the side. What's the derivative of cosine? Negative sine 3x times u prime, so times 3. Fix it. 33 cosine 3x, right? Done. Minus 3 times 7, 21 sine 3x. That's it. Question 11. Given y equals 10 sine 6x, what's the derivative? Take always the coefficient, always take it to the side. Derivative of sine, cosine 6x times u prime. What's the derivative inside? 6. 6 times 10, 60 cosine 6x. Very easy. Question 12. Integral 42 cosine 6x dx. Always coefficient, take it to the side. Okay, what's integral cosine? Negative sine. No, sine, it's just sine. Right, it's just sine. Okay, whoa, no, so what am I doing? With integral, always do 1 over a first. So 42 times 1 over a, 6, right? Times sine 6x plus c. 7 sine 6x plus c. That's it. Okay, thank you so much for watching, and good luck.